Once again, I welcome everyone for this session on Industry 4.0 practices. We have with us Mr. M.V. Subramanian, also known as MVS Money, member of the NASSCOM SME Council. Mr. Money is a serial entrepreneur and management specialist with a special focus on business strategy, execution, process, and deal structuring. He is the co-founder and managing director of Future Focus Infotech Private Limited, a leading IT staffing enterprise with more than 3,500 employees and operations in India, Middle East, and US. Mr. Money is a director in Native Angel Network, a member of TIE Chennai, and advisor in Grad Valley Center of Excellence in Data Science. He is on the advisory board of Sahyadri College of Engineering, Mangalore, and has co-created a first of its kind Center for Mechanical Engineering Startups and Incubators, thus making Sahyadri the first campus in India with an integrated high-tech manufacturing facility. So without further ado, I'll now hand over the stage to Mr. Money and request him to introduce our speakers and lead the session, please. Over to you, sir.
Thank you, Neha. One of the things which you left is I'm part of SICCI too. I am the technology chair for SICCI, and I am the moderator between both SICCI and NASSCOM to bring it to the platform. Thank you. Thank you once again, Neha.
Thank you, sir.
And I would like to invite Mr. V.N. Shivshankar, Vice President of SICCI, to give his welcome address. I have to introduce Mr. Shivshankar. Mr. V.N. Shivshankar, Vice President SICCI, is a founder of VNS Legal, which is a well-known firm in a corporate law firm based in Chennai. Mr. Shivshankar, after completing a graduate in commerce, went on to complete his law degree from the Madras Law College, securing the top rank in law. He is also a member of Institute of Cost and Works Accountants of India and a member of Institute of Company Secretaries of India. With a rich experience of working in various large corporate houses in India, in the legal, taxation, and compliance division, he has built up a significant expertise in financial services sector. A passionate academician, he is also a visiting faculty at various professional institutes in India speaking on corporate laws and foreign exchange. Welcome, Mr. Shivshankar. I would like you to address the gathering.
Thank you, Mr. Mani. Good afternoon to all of you, and my special thanks to all of you for joining us today. I would like to welcome Dr. Anand Seshan, Chairman FG Group, Mr. Babu Ramachandran, Senior Management Professional, Alstom India, Mr. Prashant Deshpande, Expert Global Solutions Chairman, Mr. M.V. Subramaniam, our own SICCI person, Chairman of the SICCI Technology Committee, and also NASSCOM SME National Council member. Once again, welcome to all of you, and I would like to extend a special thanks to NASSCOM for partnering with us for this session. SICCI is an organization, it's a chamber of commerce based out of Chennai, completed more than 110 years. We are in the process of continuing to engage with industry to see how we as a chamber of commerce can act as a nodal interface, and please, wherever you feel that there is an intervention required, a representation required, or a policy document required, feel free to reach out to SICCI. We'll be more than happy. You can also visit our website to make sure to see what all activities we have planned for this year. And we would be very happy if you would also join us in those activities. Happy to note that today's seminar on the SME front is an extremely important area. The MSME segment contributes to a significant percentage of our country's GDP, and only in the last few years it has achieved the recognition which it should have. Post-COVID, economic conditions have significantly changed, and I'm happy to say that the SME sector continues to play a significant role in our economy, bouncing back much sooner than expected. So even though initially every country wanted government incentives, same in India as well, government had also been supportive of this fact and continue to provide some incentives to the sector. As an industry body, as an industrial sector, we need to see how to take this challenge, how to move ahead in this challenging times. Manufacturing is an extremely important component of our economy, and with the industry undergoing significant changes due to the post-COVID scenario, manufacturing also has to constantly meet those changes. And I'm sure that today's event will open out avenues for all of us to learn from each other and progress within each segment of our business. I'm happy that our technology committee under Mr. Mani's leadership is taking these efforts and looking forward to more valuable programs and contributions from him. I would not like to take any more time, and I would like to wish all of you a great learning experience and looking forward to all your participation in our programs in the future. Thank you.
Thank you, Mr. VNS. I think I take the pride in inviting Mr. Balachandar to give a few words. I'd like to introduce Mr. Balachandar, who is president of AIMA, who is also partner to SICCI in most of the conferences or the engagement which we wanted to do. AIMA is one of the very important part of the manufacturers associations. So I'd like to introduce Mr. Balachandran. M. Balachandran is a chartered accountant and chartered secretary with 47 years post-qualification experience in finance, accounts, loan syndication, and company secretarial works. Studied at Madras Christian College High School, BCom from Loyola College in 1970, chartered. Accountancy in 1974 and chartered secretary in 1981. After 10 years of service in bank, that is Bank of India, and financial institution, started practice in 1984. A chartered accountant, main area was project consultancy and was approved consultant of IDBI, ICICI, IFCI. Entered business in 1989 to manufacture automobile components in Ambattur Industrial Estate. The company Delta Control System, an ISO 9001 certified company, is supplying to leading automobile tractor and genset manufacturers. He was a financial advisor to Autolec Group of companies in Ambattur Industrial Estate, served as an honorary general secretary of Ambattur Industrial Estate Manufacturer Association in 2012, and presently holding posts of president AIMA and director and advisor to Chennai Auto Ancillary Infrastructure Upgradation Company, which is tasked with maintenance of infrastructure of the estate. Also advisor to the Premier Machine Tool Exhibition ACME, conducted biennially by AIMA. Received the Business Transformer of the Year Award in 2018 from the Institute of Chartered Accountants of India for MSME category. I welcome you, sir, and I think you are going to play a major role in terms of connecting both IT and Industry 4.0 to our industries. Thank you very much. I would like you to address the existing gathering with your information. Thank you very much.
Thank you, Mr. Subramaniam. I thank the Vice President, Mr. Shiv Shankar, Mr. Subramaniam, the Technology Chairman of the Technology Committee in SICCI, and all the office bearers and other speakers here for having invited AIMA today for the session. Generally a party to whatever SICCI is interested in, so we are very happy to be. So as the president of AIMA and owning a small unit, the pandemic has taught a very big lesson to MSMEs, that there was a feeling that in MSMEs that a company will open along with the owner coming in and close up when the owner leaves the company. So it looked as if everything had to be handled by him. And this pandemic made it look very obvious that it was not the case. Most companies were being remotely run by their own managers or supervisors. And those companies which had already become tech savvy and were 24 data sharing, they could weather this pandemic much better than those companies which were hands-on and trying to run everything by the owner himself. So that was one positive thing that I could see that pandemic has taught, that they have to accelerate whatever they were thinking in terms of using technology to manufacture or run the companies. As we years ago, there were many times where people were thinking about this, but somehow the technology or the skilled labor was not available to implement and it was not in their thought, but this pandemic has accelerated all that. And those companies which were remotely managing and digitally connected devices, they weathered this well. This shortage of labor coupled with technology being introduced in MSME is going to be in this industry 4.0. And for this, I feel there is inadequate skilled manpower right now. So I think the leading role has to be played by the government institutions, academia, industry partnership. And also I think the MSME Development Institute has started a scheme called Champions. This has been introduced in 69 centers all over India. So they are also into trying to introduce this new concepts to the MSMEs. So I think leading industrial associations need to also handhold some of the small companies to better utilize the technology initiatives. This MSME looking forward is, as I see, a Tally ERP and not a SAP ERP. As you know, SAP ERP is a good production, marketing, sales, and it's a good scheme, but then it requires a very sophisticated implementation group. And what we have seen 20 years of that computers, when the computer first came to the industry, people had bought a computer, but you had somebody trying to put in a software to run your business or your finance. And if the gentleman took a job or it was not available, the whole software stopped and they could not use it. When this Tally arrived, or even Wings or other software came, it was a tailor-made solution that was implementable. Industry-specific products were introduced, and everybody got people who were capable of running this software. So I feel that even in Industry 4.0, the imperative need or the initiative is immediately to have a specific software being developed for industry-specific application, which can be readily implemented by companies. And I think that is what is going to make small companies adopt these processes. And a few days back, there was a gentleman who came to IMA, and he was professing that he could implement Industry 4.0. And what he said was really a revelation to all of us. And he had demonstrated that, especially in a manufacturing company, that with digitally connected verniers, micrometers, height gauges, air ring gauges, and some reasonably simple attachments to the grinding machines that can transmit data. At the click of a button, without human intervention, all the data could be transferred to a central console. And that data can be interpreted and the decision taken based on that remotely by the management. So that was something that really made, because otherwise the people felt that the machines have to be installed with their own data transmitting devices, which was not possible because everybody had legacy machines. So this is what I think is going to drive 4.0 in small scale units. I think the people who are professing this scheme of things should ponder about this and come up with simple solutions that can be adopted for MSMEs. So with these words, I look forward to listening to the experts in this field and getting to know more about Industry 4.0. Thank you very much, and thank all the participants who have come here today to listen to the experts. Thank you very much.
Thank you, Mr. Balchandar. I think you have set the context. I have a less job to do now. Because this is what exactly I wanted to deliver, but possibly I'd like to tell why I was interested in this association to go together like NASSCOM and SICCI. That is most important for us. Because both the organizations, SICCI wanted to improve the productivity of the small and medium industries. NASSCOM one side wanted to also set up this Industry 4.0, a kind of a specialized attention to that, where Mr. Deshpande was actually heading it. I happened to meet Session because I am part of regional council in Tamil Nadu also. Dr. Session and me went to Mangalore to set up this industry in a college. That time he was talking about how a small and medium industries can benefit because of this Industry 4.0 revolution. And that made me think that I should be able to even set up a a kind of we discussed about it for small and medium industries, how to support it, how to do the intervention with the smaller organization. That was very interesting conversation. That made me think that since I have access to both the organization and if you look at the expenditure of Indian industry in IT is around $8 billion. And if this money can be even saved and we will be able to do the activity inside, and the SME IT company can serve the SME manufacturing company. And if there is a model which can be arrived, and that is going to be the great model for us to work. Gone on those days that IT is independent by itself. It is going to be only industry focused, like we say fintech, manufacturing, industry 4.0. All these are going to be integrated with other industries. Unless we all join to work together and see what the problems are in the industries, and the IT can provide the solutions for them, that is going to be a win-win for every one of us here. I think everybody has a problem for how to implement it, what is the cost. I was actually taken by surprise when Mr. Sheshan was talking about the cost is not so much and it can be implemented. And then I went and searched in the government also. There are funds available by the government, but the accessibility of these funds, SMEs doesn't spend the time, or they do not have the patience to go to the government, make this, apply for this and get this grant and then work on that. I just checked with MSME, there are some funds which is not been utilized at all, but it has to be categorized as like innovation, or we have to categorize in some way and then get this fund. But all these are a kind of an independent research or search I was doing it. Then I thought we should, 1 year back, NASSCOM decided to go along with SICCI to do a road show on this Industry 4.0 across Tamil Nadu. Unfortunately, this COVID has stopped us in doing that. And we wanted to have at least start this program now, so that we continue this program by doing an implementation trials in small and medium industry by taking up clusters. This is what some discussion we had some point of time. So now I do not want to take more time. I would like to introduce the panel. This whole discussion is going to be of two sort of things. Like one is the experts will talk about how they look at this Industry 4.0, how this can be implemented. The second is we do not want to leave with that. We wanted to give a case study from each one of the industries. There are 3 demos which has been organized so that the people who are there can visualize how this has been done and how it will be useful for their own organization. I would like to introduce the panel, and I take it from the way the alphabet is, like Mr. Anand Sheshan. Dr. Anand Sheshan is the chairman of 5G group of companies that specializes in smart manufacturing products and solutions. Headquartered in Canada, the group has operation in Mexico and India, two in Chennai. Anand has been consultant to Fortune 100 organization worldwide for the last 3 decades in the areas of robotics, automation, of late digital manufacturing. He was an invited member of special task force set up by Industry Canada to explore the viability of applying advanced manufacturing technologies as a strategy to build competitive advantage in the Canadian manufacturing sector. Over the last three years, he has been an evangelist for the application of Industry 4.0 technologies to small and medium industries. In particular, he has been involved in the ideation of 100+ successful implementation of Industry 4.0 to the SME sector to date. He is presently a member of board of directors of MESA International, a US headquartered global community of manufacturers and industry leaders, and a strategic member of the SME affinity group of the US Department of Energy Center and for Smart Manufacturing Innovation Institute, that is CESMII. Over the last couple of years, he has been actively involved with the Center of Industry 4.0, that is C414, based in Pune, National Productivity Council, Chennai, and as an advisor of smart manufacturing to the Central Manufacturing Technology Institute, Bangalore. Anand receives his PhD from University of Toronto in 1991. He has developed 2 online courses for the Asian Productivity Organization, Productivity Organization Japan, on smart manufacturing, and has been recently invited by CRC Press to write textbook on the practice of predictive maintenance 4.0. He has been an invited speaker to many international forums on manufacturing automation and has won several awards for innovation and entrepreneurship. Welcome, Dr. Anand. We are here to listen to you. Anyway, I have to introduce a second speaker of this panel, Mr. Babu Ramchandran. Babu is a senior management professional with wide experience in the industry, having served in the automotive, OE, components and railway sectors. He has performed strategic roles leading quality management and supplier development in various organizations, managing business critical projects and operational excellence program from startup to scale up at green and brownfield scenarios. He has more than 25 years of experience in the field working with organizations like L&T, Ford, 3M, Motherson Group and Daimler India commercial vehicles. He is currently heading the supplier quality at Alstom Transport India. Alstom is a leading global player, is providing mobility solutions worldwide with engineering and manufacturing footprint in India, serving the Indian and global market. He is a graduate in mechanical engineer from NIT Calicut with post-graduation diploma in business administration from Laila Institute of Business Administration, Chennai. Welcome, Mr. Babu. I have another profound speaker, probably Mr. He's from NASCOM, but is very, very active in terms of bringing this event, and he pushed us, saying that we should do it even if it's COVID. And that is Mr. Prashant Vijay Deshpande, a Bachelor of Mechanical Engineering from Government Engineering College, Aurangabad, Master of Management Studies in Operations from Wellington Institute of Management, Mumbai. Before founding Expert Group in 1990, he has worked in Mastec as a system executive, worked with Godrej and Boyce as a planning executive. Expert Global Solution is a leading service provider in the field of information technology, engineering design solution, digital transformation solution, ADS, autonomous driving solution. Very important to note. He has delivered seminars in national and international conferences on subjects such as connected cars, emerging trends in IT, leveraging engineering and IT growth for growth of manufacturing companies, business process outsourcing strategy for US companies, product data management implementation, design automation through CAD, customization, interactive selling system. His achievements are many, but I like to read few. Expert Global, which has today 1,100 strength, has received prestigious Maharashtra IT Award from Maharashtra. Formed a joint venture with Germany company to provide solutions in ADAS and driverless car, employing over 300 IT professionals. He is past chairman of CSI Aurangabad and CII Marathwada zone. He is a convener of Water Mission Panel of CII Maharashtra State Council. He is a member of NASCOM SME panel. He was a Senate of Government College of Engineering, Aurangabad. He is a governing council member of 105 years old Saraswati Bhuvan Education Society. He is a chairman College Development Committee of SB Science College. He advises SSBES for their IT strategy and bringing professionalism in the organization. Areas of interest, which is very interesting, mentoring teams and people to take professional challenges globally. Actively working the areas of water security, road safety and solid waste management. Develop Aurangabad and Marathwada as a preferred IT and electronics destination. Pursue education at the bottom of the pyramid to build better India. Give back to the society in whatever the form we can. So I am a little tired reading all of those their achievements. I leave the panel to Mr. Babu to take it forward, and if there is any intervention, I'll be including. Thank you very much, Mr. Babu. Take it forward. Thank you.
Thank you, Mani sir. Good afternoon and welcome to all of you. Without much further ado, I will start the. I'll share my screen and I'll start the topic which we had planned for today. It's really was a very, very fantastic interaction I had with the experts, very eminent panelists here, and of course, sharing their insights. I think thanks to Mr. Balachandran, Mr. V. N. Shivashankar for the introduction, and Mani sir as well. You have set the context clearly. I think there is definitely a clear need for this topic to be discussed, a clear need to understand what is the nuances, what is behind this. And that's also the way we have planned this discussion. We have planned it as a kind of a free exchange between three of us, trying to bring the insights. In a very simple way, we will ask the 5 why and 2 H kind of questions. We will follow a discovery path answering these questions, and I have the great support from my eminent panelists who have been quite versatile in implementing these things. So definitely we will explore these questions and try to come to the answers. For sure, we will start a little bit with a background of what is this so-called Industry 4.0 and what does it really mean. As a jargon, this has been quite popular, especially in the last few years. I think it has come into parlance sometime during the 2010, maybe a little bit before that, but more or less today, it's seen as the successive industrial revolutions. This is the Industry 4.0, which as it exists today. So I think I will not explain a lot more about the industrial revolutions, but the whole, the effort between an industrial revolution, it began with reducing the pain of human effort to make work simpler, to make make it easy to produce things, and then to mass production. And with the advent of electronics, automation came into being. And what is Industry 4.0 in this context? I think we have seen a huge power. There is a new resource, a new resource which is is available now. It is the power of data. And one of the keywords I would always associate with this is the word automation. I think this is these you can call it many ways: intelligent automation, or cyber physical systems, or smart manufacturing. So this is what is Industry 4.0, but there is much more to it. And if you go into more of the technological pillars behind it, I can quote a BCG survey. These 9 pillars are the basic pillar technologies of this Industry 4.0. And in the course of the discussion, we will definitely touch upon some of these, what it actually means. And I don't want to read out all these technologies, but it is all about autonomous robots, or about the vertical and horizontal integration of systems, Internet of Things. That's a very major topic which is coming here. Cloud or augmented reality. So all these today are slowly and surely finding their way into the business chain. And we do see that there are many applications where across each and every part of a manufacturing process or a business chain, we would find these applications getting into it. In short, it's all about a technology empowered automation, which is to improve the the business objectives of quality, safety, productivity, and competitive advantage. I think the last point here would be something very significant element in this whole aspect. It's not just about maintaining a business; it's about deriving competitive advantage from innovation. So moving on to understand where do we stand in an industry, and where is what is the background again in an industry. If you were to look at a typical value chain, you have industry from the input, the raw material, or the say the steel mills, or the design providers, and at the heart of this is the SMEs. And the SMEs have therefore their customers, the OEs, and at the end of the chain are the consumers. So this whole chain is what we are trying to sustain, and the SMEs are the core of this. And I think nowhere much more significant than now, in the recent decade, we have found that small and medium enterprises really form the backbone of this entire industrial value chain. And not only that, they can drive changes, they can drive innovation in a way which is never seen before. What are the factors? I think all of you know the factors which an industry deals with. There is material, there are the many M's: material, man, machine, methods, and we have discovered M's of metric, media, and never to forget Mother Nature as one of the fundamental M's. So In this interaction, in this value chain, businesses face the problems and the very obvious business challenges, business problems of productivity, quality, flexibility, and speed have become very critical now. And of course, we always have environment, safety, and cost and profitability always to tackle with. And also the aspects like training or the communication, working on the working conditions, these form a fundamental aspect of these problems which the business are facing. So this is and kind of an exploration to what is today's scenario, what is industry. We have now to get into the topic of what is Industry 4.0. So here is an interesting aspect which I would request Dr. Anand to bring up. I think from his point of view, how this 4 dimensions are applied.
Thank you very much, Mr. Babu. Are you able to hear me clearly? Yeah?
Yes, sir.
Yeah. Okay, thanks a lot. And as Mr. Babu has eloquently presented the entire value chain and how Industry 4 impacts the entire value chain, one can then ponder how can we encapsulate that concept in a very simple manner for presentation to SMEs, and how we can start implementing in a bottom-up manner the concept of Industry 4. That led to this, this concept of 4 dimensions and 3 connections. The 4 dimensions are, as you can see on the right-hand side of your screen, smart business process, smart solutions, smart technologies, and empowered human. These are all connected. So the Industry 4 concept itself was conceived to transform traditional processes to smart business processes. So that is the first motivator for Industry 4. And smart business processes need to be implemented by using smart solutions. And smart solutions need to be enabled by smart technologies. And all of these will have to be experienced by an empowered human. So if you have these 4 elements, then it is a smart Industry 4 solution. Let me explain this with an example. That's probably a very common example that all of us know. I think in every manufacturing shop, we will have a meeting at around 9 o'clock or 10 o'clock in the morning in the war room, where all the heads of all the departments will convene, and they will talk about the performance of the previous day or the previous shift. They'll talk about what was not working, what did not work, what could be improved. So there is a lot of back and forth discussions using papers and records and perhaps statistical analysis of the performance of machines, of people, of products, of parts produced, materials, and so on. So let us say that is the traditional process of sort of monitoring and improving. Let us say that we want to establish a smart business process where the same interaction can be happening instead of post-mortem the next day or after the shift. If it is happening in real time, it has to happen real time concurrently. And let's say all the stakeholders, the quality head, the maintenance head, the production head, the warehouse materials manager, all of them are connected and can interact in real time. Let's say that is the smart process we want to create. So that is the first dimension, smart business process, transforming from a physical meeting post-mortem to a monitoring of the process in real time. So that is the first dimension. So let's say we imagine that, okay, we need this smart process. These are the parameters of smart process. Everybody should be concurrently updated. They should be having real-time information in their fingertips. So what do we need to implement that? We need a smart solution. The smart solution will be in the form of a software app or an app in a mobile phone. Everybody has that, right? So app. So that can be sort of accessed by all of the parties concurrently, and we can get the information that is required real time. So we need some kind of real time information that the app should provide and some level of interaction the app should provide. So we have constructed the requirements of a smart solution. Now that smart solution requires technology in the form of actually a software, the platform for the software, the wireless connectivity or the network connectivity for enabling the connectivity from the machines and from people to the app, and any other a tablet or any other display mechanism like a tablet or a smartphone. These are the smart technologies. So the smart solution is enabled by the smart technology, but in the end, what happens is that at the end of it all is an experiencer, which is the human. The human experiencer is empowered with real-time information. Here we started off by converting a manual process to a smart process. We implemented that in terms of a solution. We enabled it with technology and provided the operators, the stakeholders, the managers to have real-time information in their hands. This is a quick example of how an Industry 4 technology can be implemented, practice can be implemented. So these are the 4 dimensions. In any Industry 4 practice, we can identify these 4 elements. So if you identify these 4 elements and clearly define them, then your actual project goal is very clear, and most likely it will be a very successful implementation. That is fine. So we have these 4 elements, but how do we implement these 4 elements from an SME context? In SME context, we are not talking about very fancy robotic systems, autonomous systems, or I mean, not essentially. It is the higher fancy stuff is required for an SME. SME might require very a minimalistic approach. If you want to take a minimalistic approach, you go bottom up. So what is so the bottom up? If you have to build a solution in terms of Industry 4, one word that one has to always remember is the most important word is connectivity. In Industry 4, you connect things, you connect machines, you connect people, you connect the ecosystem. These are the 3 connections that are most important. So if you look at that, these 3 connections are mentioned in the figure at the bottom there. The lowest level connection is the edge connections. Edge connections are basically connecting machines to an IoT or an IoT sensor to a particular edge computer. Edge computer is just a device in the plant itself. You don't need a sophisticated server. You can have an edge computer in the plant which can connect to all the machines and collect data. This previous example that I discussed, you needed to collect data for real-time monitoring. So for collecting data, you can collect it through IoT sensors and devices. The second level of connection is the solutions that we talked about, smart solutions. The smart solutions are apps. So one can build apps in a standard way, like how you have Android apps today. You can have a standard app library. There are platforms that allow us to develop apps in a very simple way for different applications, and can be multiple users can use those apps. It can be reused. So those applications are the second level of connection. So the apps, what they do is they are connecting to, so if you have an app in quality, it can connect to production. If you have an app in maintenance, it can connect to production. If you have an app for energy energy reduction, it can connect to production. So you can actually between applications, between the different functions of a manufacturing, you can do optimization. We will discuss those in an example later. So you can optimize between production and energy. You can optimize between production and maintenance. You can optimize between quality and production. So all of these optimizations are possible when these apps interact. And the apps also have to interact vertically with the corporate system. The corporate system is the one which actually provides the information on orders, sales orders to production orders. They have to be integrated to the production. So that is the integration that is a second layer, horizontal integration between functions and vertical integration with the corporate. The third level connection is the highest level connection is the connection between the various members of the ecosystem. Who are the members? The suppliers, the vendors, then the OEM, the end customers. All of them can be integrated. The logistics suppliers, all of them, as Mr. Babu was showing the previous slide where the entire value chain was presented. All of them can be connected in the low cost ecosystem connections. All of them, the three connections can be effected in an appropriate manner without having to using a minimalistic approach without having to spend a lot of upfront capital, which is the main theme of this discussion. The discussion today is how can we enable SMEs to sort of start the journey of Industry 4. And with this concept of 4 dimensions and 3 connections, we can definitely make a start in a very, very minimalistic way, but in a very useful way.
Thank you, Dr. Anand. I think very clear, and we have more case studies. We have a lot more information to showcase the kind of concept which you were explaining. Here, when we looked at the question why, so really it's important for us to understand really why is it required. And there are so many myths in this story which we heard, and also the fundamental question for me or for SME is actually why should we? So what's in it for what's in it for SMEs is a big question which we frequently encounter, and already our speakers who at the start already highlighted this. So we need to bring out this case really, why is this important and what's in it for an SME. So here I would request from your side to go with what your findings.
Thank you very much. Now, this is a very interesting finding that we made across about 500 SMEs and across four different jurisdictions. We had SMEs, we surveyed SMEs in India, in South Africa, in Canada, and in the US. And the results are compiled here. We asked them what are the major market challenges they were facing, what are the internal challenges they were facing, in an effort to see whether Industry 4 makes any sense to them, I mean, contextually. And we got the answers from the various jurisdictions were more or less similar. Maybe the first and the second greatest challenges were probably swapped, but more or less the top three challenges for the market, the top 3 challenges for the internal challenges were exactly the same. So what were the challenges? Demand volatility was the #1 challenge across the 4 jurisdictions. Cash flow was a major problem. Tight margins were a major problem. And in the case of internal challenges, we had scarcity of skilled labor. I think that Mr. Balachandran was talking about that earlier. And capital scarcity. And then you had uncertainty in raw material availability, unplanned downtime. The challenges were all quite similar, even though in terms of the industry verticals, the way in which they actually the embodiment of those challenges were different, but the challenges were conceptually the same. So the actual target segment we surveyed were very small companies to medium-sized companies. So from 5 million to 200 million. Now, so once we asked them about these challenges and asked them whether they believed Industry 4 can solve these problems. Because in general, by definition, Industry 4 must address these problems. I talked about business processes, converting a traditional business process to a smart business process. Why did we need to do that? We need to do that to gain some competitive advantage, as Mr. Babu was saying. Competitive advantage comes from improving your productivity, improving your quality, improving safety, improving the optimizing the usage of resources, and being able to adapt to demand volatility. And then therefore, you're able to achieve much more than what you could achieve earlier. So you're getting more out of what you have. So when we ask the question, whether do you think all of these challenges that you're facing, are they going to be addressed by Industry 4? We got some interesting answers. Next slide, please, Mr. Babu. So what we got from the Industry 4, from the industry was that Industry 4 is not affordable to SMEs. It's not for us. Industry 4 requires sophisticated network infrastructure. Industry 4 cannot work with old machines. Industry 4 required skilled IT staff, and Industry 4 requires a long duration for implementation. And therefore, the SMEs were not very much believing that Industry 4 is going to solve their problems. They have got other, so even when we wanted to approach them with some government funding to start implementing Industry 4 solutions, there's a lot of skepticism, because the way in which Industry 4 is being sort of understood or perceived today is that it is for the bigger companies, it's for the larger companies and not for the small companies. And the small companies' problems are not going to be solved by Industry 4. But then let us look at some facts of Industry 4. So the first point that came back was Industry 4 is not affordable. Today, we can see in at least the 4 jurisdictions that I'm talking about, companies in the range of 5 million to even 10 million can start off on Industry 4. They've successfully implemented Industry 4. And as Mr. Balachandran, I think, was talking earlier, they are making a change. They are making a difference. And then Industry 4 does not require sophisticated network infrastructure. It needs for certain applications. And not that I'm not saying that it is not required. It is not required for every application. One can start with a basic internet. A basic internet should be sufficient for Industry 4. And then legacy machines. Most of the SMEs do not have computer controlled machines. They have very old machines. So what is the big point of having Industry 4 when we have old machines? Yes, we can use legacy machines as well and digitalize them, bring them into the digital thread. You know, it is not necessary that these legacy machines should be islands of automation. They can be connected to the digital thread. All of the information that you are getting from a computer numerically controlled machine, or a computer controlled, a PLC controlled machine, or a DCS controlled machine, you can get it from a simple manually controlled machine by use of IoT sensors and connections to those machines. So that is a big revolution. That is going to be helping the SMEs, because SMEs are not going to be able to do what I was explaining earlier, that example of monitoring the performance. They can monitor the performance of even legacy machines sitting in their control rooms or in real time. So legacy machines can be connected. Then IT requires, the Industry 4 requires skilled IT staff. No, it is not requiring skilled IT staff. That is where the smart solutions come to the picture. Smart solutions are supposed to work like a WhatsApp. If somebody can use WhatsApp, they should be able to use smart applications for controlling manufacturing processes. So the kind of skills that are required for training somebody to work with Industry 4 solutions is very less, because people are conversant with working with apps on their mobile phone. And finally, Industry 4 require a long duration for implementation. We can build solutions, Industry 4 solutions, from a bottom-up manner, even within half a day. Of course, not all applications are going to be built within half a day. Some of them can even take a month or month and a half, depending on the scope of the solution. But if you're looking at taking a minimalistic approach, then one can very safely say that it is not something that is going to span 3 to 4 months or 2 months or 1 month or even 2 weeks. It can be done within a week, which is affordable for the small and medium enterprises. They don't have the time to spend 1 month on implementation. Here we are talking about very quick implementation, incremental evolutionary process of implementation, and it can be done from even within half a day. Next slide, please.
Thank you, Doctor. So you are always talking about a minimalistic approach. So I think here we would like to hear from you on this.
Okay, minimalistic approach in the sense that, once we have in an SME situation, we are looking at the problems that we talked about in the survey. How can we address those pain points? How can we address those challenges? Instead of coming up with a massive top-down plan for Industry 4 implementation, we are looking at bottom-up. Let's take the top 2 or 3 pain points and start implementing. And for instance, the first immediate sort of problem that one needs to solve is one may need real-time visibility of operation for an SME. Real-time visibility meaning, as I mentioned the example, I would need to know the performance of whether I'm able to deliver today to my customer. And when I'm delivering to my customer, are there going to be any downtimes? Are there going to be any quality problems? Are there going to be any labor problems? All of those I need to know when they are happening so that I can take some action. And then the second thing that one would need in an SME situation is one accurate version of the truth. Because of manual entries, at every point you have some numbers being entered. Some of them are entered immediately. Some of them are entered later on. There are errors in entry. So as a result, they understand what is going on, understand the pulse of the plant. It is very difficult because you don't have one accurate version of the truth of what is happening. Even if there is a problem to solve, you need to have the power of data, as Mr. Babu discussed earlier. Then you need to understand let's say that you have now real-time visibility. You have one accurate version of the truth. Then what can you do with it? You can start understanding the root causes of your problems. What is the root cause of downtime? What is the root cause for your material loss? What is the root cause for rework? These are problems that are fundamental to the operational efficiency of the organization to improve. So one of the major challenges is cash flow is tight. Now, cash flow is tight because of inefficiencies are there. If we remove inefficiencies, you're saving cash. So these three, as you go on, so you can start understanding the causes of waste, you are removing them, you are improving your efficiency, your profitability improves, and your cash flow also improves. Then traceability. Your traceability is a very important aspect again, in order to ensure that if there is any problem, there is the rectification, remedial action is not costly on one side. And then when your customer is going to come back to you and ask questions, you have enough data to show whether your part of the manufacturing value chain was the problem or not. And it is a mandatory requirement for most of the OEMs to have a very good traceable system as a supplier. So instead of maintaining paper records, and paper records are very hard to maintain, to identify or trace a particular manufactured part even a week ago is very difficult because of the scores and scores of papers that you have to share. You have to store. Now with digitalization, the traceability becomes so easy. It is a digital record. It is stored in the computer, in the memory. All that you have to do is to click on that particular date you want information, and you get the information immediately within a second or two, which will take at least half a day or a day. If it is going to be a month ago, it will take even more time. So these are important things that SMEs need. And finally, reduction in labor errors and omissions. See, when SMEs do not get very sophisticated, very qualified labor, they are trained by the SMEs and they're put to work. And when there is, and also they have the scarcity of skilled labor is one of the major issues that came back in our survey. So when you have only one or two skilled labor, you have a lot of unskilled labor who have to be trained most of the time. You need some help from the digital systems to de-skill the operation so that part of the validation, part of the error proofing is done by the system itself, and people who are not fully skilled can also operate or also perform certain tasks that are only previously performed by skilled labor. So by de-skilling operations, you are able to tap into a larger labor force, and you are not held hostage by one or two or three members in your labor force who are skilled. So these are very important problems of SMEs, which can be addressed in a minimalistic manner by going bottom up. Now, this is the immediate sort of advantages you can get from a minimalistic approach. But the mid to long term is even more interesting. As an organization, the SMEs will improve their capability because of the monitoring and because of the improvements that are happening continuously. They'll be able to improve their capacity. Okay, effectiveness and efficiency will improve, so the capacity will improve. The supplier visibility, they can integrate to their suppliers and they'll be able to get a very clear picture of whether material is available or not, one of the major problems that we got back. Then, as Mr. Babu was saying, competitive advantage, it's a very important thing. By being very nimble, you become very nimble. The organization become nimble because of digitalization. By being nimble, you can respond to your customers faster. And not only that, you will be able to make your quotations much more accurately because of the digital information you have. So if there's a new part that you have to make for your OEM, you will be able to cost it better. You will know the unit cost efficiencies that are needed for that particular part, what kind of margins you can apply, can be more competitive. And finally, all of this and your systems, the digitalization, the traceability, by harnessing the power of data, you are going to be attracting more customers. Your market share is going to improve. So that is the long story. That's a long-term sort of benefit. But in the immediate term, you get some advantages which are by themselves very, very justifiable for an investment in smart manufacturing or Industry 4. Babu, you are.
Yeah. I think that was a very clear exposition of the story behind this so far. I think here let's hear from Prashant about the interesting part of today, what's happening in the market. So Prashant, some words from you on this.
Yeah, sure, Babu. Thanks, Babu and Anand, for setting a clear platform for understanding importance of embracing new age technology concepts of Industry 4.0 by SMEs. If you can see on the screen, there are a number of devices which are getting connected every year, and that number is multiplying. And last year, it is estimated that the number of connected devices are around 50 billion connected devices. So what is Industry 4.0? In very simple terms, it is making equipments intelligent, smarter, and also making factories connected and smarter. So the equipment which is not able to convey anything on its own, you put sensors, you put some data acquisition, and it starts conveying, how much I have produced, what is my temperature. So making your equipment smarter is the smartest thing you can do. While it is churning out the data, now data is very important for me to take business decisions, which Dr. Anand has elaborated, that I need to take right decisions at right times so that I can put right people on the job and right strategies, and my return on investment can be higher. So in 2020, it is estimated that there are about 50 billion devices. CAGR for machine-to-machine market is growing at phenomenal pace of 50%, and the overall spend or economy itself is about $4 trillion. Now, as SMEs, Babu had shown in one slide that we are part of the entire chain. So we cannot go away from embracing these technologies. And this is the opportunity for manufacturing companies, SME companies, and SME IT companies, that there is going to be data, there are going to be apps which are required, there are going to be millions and billions of machines which are going to get connected over next 4 or 5 years. So if I am SME IT company, I need to understand what it takes, upgrade myself, and capitalize on this opportunity. So I personally believe that India is very nicely poised to take a leading role as a Industry 4.0 provider, and also implementing in the manufacturing domain. Yeah, thanks, Babu.
Thank you.
Yeah.
I think we have a lot more to come, and you have already hinted. The first thing is it's a huge opportunity for the entire value chain. So I think it's now time to get into the topic of the what has been applied so far. In the interest of time, what I would request is we have several case studies where you can give a quick brief about the problem which was addressed, And we are very interested to see really what has been the cost of doing this and what has been the result, and what's the kind of, what is the, where do I get my return of this? So first we start with some case study from Dr. Anand, and afterwards we have also some case studies from Prashant, both of them who have made very, very pioneering work in this. So request you to give a very brief outline, and I think let us look at the solution, what is actually delivered, as we have more to cover, and this is definitely interesting news for most of the participants.
Yes, thank you very much. So the first case study is about how you can optimize between production and energy. Energy costs are universally increasing, escalating, as we all know. So optimizing energy costs with respect to production is the topic here. So that's the pain point that we want to address. And we can address that by means of connecting an IoT sensor to the energy guzzlers in your plant, which could be any machine that is going to consume the most energy. And it could also be the utility. It could be a boiler, it could be a chiller, whatever is your energy guzzler. We can connect an IoT sensor, you start monitoring. You just, when you monitor the energy consumption, you can monitor it according to, in different dimensions. You can monitor according to a particular time of day, particular season, or you could monitor according to a particular product that is produced. The energy required to produce a particular unit product is called energy intensity. That energy intensity is a fantastic metric to have. If you know how much does it cost you to produce a particular part, you will be able to quote, first of all, for that particular part very well as you will be able to understand whether when you produced 1,000 parts or 10,000 parts, whether the energy costs have been proportional to what one would have assumed it should be. So the energy intensity is the one that integrates the production, the throughput with the energy costs. So you link both of them and you try to optimize that. How do you do that? The system can be made intelligent enough to track a baseline for each of the parts that are produced. For each part, you will have some kind of energy signature. And if the energy signature is not followed, the baseline is not followed, a small alert can come to the operator saying that this time for this part, we expected only so many kilowatt hours to be used, but it is 20% more is being used. So immediately one can go and rectify the problem or address the problem. So that kind of monitoring, baselining for every part, baselining, first of all, understanding the energy guzzlers, baselining for every part, and measuring the deviation from the baseline is a very interesting way of monitoring and optimizing between production energy. This particular example, this implementation costs between 5 to 10 lakhs, as you can see in the picture. And it provides you a significant savings. In a year, you can gain up to 20 to 30%. I put a very conservative 20% savings. And more importantly, one can get a competitive edge in winning new contracts, because when you have a part, you can simulate for that particular part how much energy is going to be used based on some similar part that one would have produced before, or based on the actual process cycles that one has to follow. Either way. So the payback again is within a year. And this is one very minimalistic approach to implementing Industry 4 production energy optimization.
So here, this is where we have sensors attached to the machineries which give us this energy intensity information.
Yes, we can use current sensors or energy meters.
Okay.
Either way, you can connect it to the machines. From the machines, you get the information, and the rest is all analytics, which can be done by the edge computer that I've talked about. So all of that is sort of, the first part is to collect the data from the IoT sensors, and then you can present the data in whichever form. If you want to make a baseline, you can do it. If you want to just have the energy monitoring of all of the guzzlers, that's also an idea. As you can see some graphs here, but one could basically understand the energy consumption across the plant by just connecting some simple sensors.
Interesting, interesting. So let's see another case study on this application of Industry 4.0. I think it's another interesting case study from Dr. Anand. Yeah.
This is a very interesting one. I think Mr. Balachandran earlier mentioned this, I think, and also my esteemed colleague Prashant was talking about making instruments smarter. This is a very simple integration of supplier and OEM, or many suppliers and an OEM, where the quality of the suppliers are normally there is a quality plan that the OEM provides to suppliers, and the suppliers follow that quality plan and dispatch the goods when the quality plan is approved by the supplier's quality inspectors. And it then comes to the OEM. The OEM has a quality inspector at the entry point of the OEM, and they approve or reject based on their own assessment of the quality. Now, there is an inefficiency here because the same thing is done twice. And also, there is no monitoring of the compliance of the quality plan at the supplier end. And there is no need for a validation once the quality is approved by the supplier. There's no need for another validation at the OEM's end. Because of the lack of technology or lack of validation mechanisms, this particular process is being followed. Now, let us imagine this particular case where let's say that some automotive parts are being manufactured in this case, and there are dimensions that need to be measured. And there is a quality plan the supplier has provided for measuring dimensions. For each part, let's say there are 5 dimensions to be measured. And they are going to be measured by vernier calipers or dial gauges. Now, these vernier calipers and dial gauges are going to be they'll have a digital attachment which can measure, which can basically send wirelessly when the operator is measuring the part. It can send automatically wirelessly the measurement to an app in a smartphone or in a tablet. Now that app will then ensure, the app will be a method to ensure that the operator is going to check every part. So if there are 5 according to the quality plan, if there are 5 dimensions to be measured in a particular part, the system will prompt the operator, the application will prompt the operator to go to the next dimension and measure it. When the measurement is done, automatically there is no need for the operator to enter the data. As soon as the measurement is done for the second dimension, it again automatically gets sort of input into the application. Similarly, the 3rd dimension, the 4th dimension, all of those, when they are measured, they are automatically entered into the application through the wireless connectivity. So when the part inspection is complete, then the system will say, okay, you have completed this part, go to the next part. Now that information is stored in memory and it is available to the local quality inspector and to the OEM quality inspector. So once the batch is done, you get the complete information about the quality of the batch instantaneously available, both at the supplier's own quality management as well as to the quality management organization of the OEM. So this eliminates the need for any validation at the entry and also eliminates the external failures for the supplier. The supplier need not be worried because the supplier will know the quality of the batch before it is dispatched. The supplier will know whether their operators have followed the quality plan accurately. So the accuracy and completeness in the compliance of the quality plan is established. And for the OEM, the quality is established even before dispatch. So they are not going to get surprises in their assembly line when something doesn't work and they find that, oh, there is a problem with this particular part, and the hole is not, the tolerance in the hole is not correct. So that kind of discovery at the later stage of the game will not happen. So early, this completely eliminates the errors that can happen between the supplier and errors in the parts that are being supplied by the supplier to the client. And this has been implemented, by the way, in India in more than 150 shops. And you will get a demo of this particular application later on. Again, the cost is between 5 to 10 lakhs, and it integrates the supplier and the OEM. Both sides are going to be benefiting, and the ROI is less than 1 year.
Perfect. Quite interesting. And I think it's really something which looks very attractive, that it's very low cost in terms of that, and saving on cost of quality. I think this is one thing which would really be making big sense.
Yes.
So another example here, I think we can quickly go through this, Dr. Anand.
Yeah. So this is a slightly more sophisticated one, but again, still within the scope of SMEs. Here you can see a fender, again, an automotive example, but this, of course, can be applied to any industry. All the examples that I mentioned are not just for automotive, can be extended to any other industry. So in this case, there's a fender. The fender has, there you see some labels on the fender, as you can see. Those labels have to be stuck at certain specific locations in the fender. And for each model of the fender, different labels have to be stuck at different positions. And the number of labels are different, the type of labels are different, the position of labels are different. And if you have about 25 models in a particular line and they're all mixed, then you'll see that, you immediately can imagine the kind of problems and errors that can happen. And the positioning of that particular label itself requires lots of jigs and fixtures for each of the models. And finally, after all of that, the whole thing has to be done within 5 to 7 minutes. There's a lot of stress for the operator to complete it. It's not one operator, 2 or 3 people have to work together in order to make sure that there are no errors and the operation is done within the takt time for that particular line. So this problem had several issues. Apart from operator stress, there were lots of errors, and errors were sort of costly. And they're all external failures. So what had to be done was some kind of a smart process. Again, we talked about the smart business process. Instead of doing it manually and using jigs and fixtures, the idea here is to use a wearable, a digital wearable. In this case, we used what is called as Google Glass, a augmented reality device, a device which can, as you can see in that picture, there is what you see is what an operator sees. On the right-hand side corner of that picture, you see a small rectangle. That rectangle is information that comes from the edge computer to the operator, who is looking at the reality, which is the fender. So as he sees, the operator can see that he has to pick up a warning label and stick it exactly where it shows on the fender. So the operator gets instruction for where to, what to pick, and where to stick. And the operator keeps on getting instructions until a particular fender, all the labels for a fender are stuck. So this is a very step-by-step instruction to stick the label. It will also give you the location for sticking the label and the type of label. So the operator does not have to stress on remembering, what labels to be stuck for which model, etc., or refer to a catalog every time in a hurried manner to make sure that they are not missing the time. So all of that is served in a glass, and the operator's hands are free, so they can pick up the label, stick it where the computer says you should stick, and that computer information is in that insert on the right-hand side corner. It's a very simple operation, simplified operation now. It is de-skilled to the extent that it is absolutely error-free. Again, this is slightly costlier than the previous ones, at 10 to 15 lakhs. The main cost comes for the device, for the Google Glass, and it eliminated manual error, and the right the first time achievement was a great thing for that particular case. And it de-skilled labor and allowed other people also to get trained on the glass and use, not necessarily only skilled people to use it.
Right, quite interesting. I think this wearable devices, I think really can make a big difference, and it makes the life of a simple operation much more simple.
Yes.
I think it's a good time to see also some of the digital factory use cases. So without much ado, over to Prashant for the case.
Yeah. So yeah, thanks, Babu. If you can see, every shop floor has a set of machines. They are organized in cells, and every cell produces a part which goes to the next cell. So this engine and heavy equipment manufacturer, they define that they have certain pain areas like lack of real-time analysis and visibility into process, inaccurate method of data acquisition, manual reporting which is prone to errors, and difficulty in real-time plant performance monitoring. So what was happening was when the part is getting manufactured onto a machine, for how much time my machine was running, how many parts it has produced, what is the cycle time, what is the downtime. These are key requirements which every supervisor and a plant manager wants to know on hourly basis. And if that data is not flowing freely and accurately from the operator, then you are always chasing over there. And there is a word called chasers, which are on the shop floor. So to avoid that, what we said that we will help them with online data acquisition directly from the machine. As I said, the machine, if it becomes intelligent, the machine will tell that how much time I was running, how much energy I have consumed, how much time I was down, and then only the operator will have to give the reasons over there. So real-time OE calculation of individual machines can be done. It can be done on the cells level, and it can be done on the plant level. Then transparent downtime analysis by the operator. So there is an operator console next to the machine where if the machine is down, then you have to put the reasons, and there are some predefined reasons, and you can also define if any addition is there. And then accurate reports available to all stakeholders. They should talk on the same data. As a plant head, I should not be required to chase people to give me the data. And dashboards for all levels of management, which is available on a real-time basis. So as you can see on the diagram, you have machines. On machines, either you will have PLCs, you have SCADA, or you will have to put sensors, get that data from the machine. What is already available can be easily tracked. If not available, put right sensors, get that data into a data acquisition device, which has edge capabilities, and it is also integrated with ERP data, because you want to know when was this part produced. So it has a time and date stamp, and it is linked to my ERP sales order, customer sales order. So I have material traceability also established over there, and that can be done from the operator console. So you can have on-premise module, or you can have on cloud. So they went in for their own private cloud initially, and now they are going on the general cloud. So per machine, the cost comes to around 50,000 rupees. There was 20% improvement in OE. Earlier, the management was thinking my OE is around 95. When this was put, it came to around 75, 80. So everybody said the system is generating wrong data. We had to take a lot of effort to show them that it is generating wrong data. You were getting wrong data earlier. And then they reported after using it for a couple of months that your system is right and we were wrong. There was another revelation also that to show that you are doing well, they had defined a cycle time which was higher in the system, whereas the machine was taking lesser cycle time. So it was able to produce more number of parts, but because it was on paper, it was that way, people were happy that it was producing that way. It was implemented per machine, in anything from 4 to 6 weeks, depending upon how to capture the data. And then ROI is within 12 to 18 months. So this is one of the very successful implementation, and now it is getting rolled out at their multiple plant level. Yeah. Mr. Babu, yeah.
Yeah, quite interesting actually, and really it is a revelation that it can reveal the right, the truth
Yeah.
And then once we know the real truth, definitely improvement is around the corner. So
Absolutely.
I think thanks for this good example. Let's look at another case. And I think again, we can look at, what are the benefits of this in a more direct way from the results.
Yeah. So this is for a process industry. Earlier we saw discrete manufacturing setup. Now we are seeing a process industry. Though it is for a large beverage manufacturer, but it was first implemented in their pilot plant, which can be compared to a general SME industry in India. So they wanted to track process capability indices, whether my process is running appropriately or not, and my machine efficiency and utilization indices. So, I have various ingredients coming. I have a filler line, and when that filler, it is a dry powder or it is liquid. When it is filled, it goes onto a weighing scale, and even some milligrams, grams is very critical for them, because if you supply more, then you are at loss, and if you supply less, then your credentials are down. So it is, and also you have to know whether my machine is and my process is performing appropriately or not. So fill weight traceability is what they had stated as an objective. Improving productivity was again one of the main objective, and quality compliance. So CPCPK is a measure for process capability measurement, and they wanted it to be more than 1.33 was the target. So first was to measure it correctly, because again it was, the data was coming from operator, it was coming next day, and then it's a post-mortem. But if I know real time what is happening right now, then I can take right decisions. So no standard systems to monitor line performance, lack of means to record fill weight data, because the operator was filling it, he was ensuring that the weights are correct, and then sometimes he used to forget to fill up the weights. Then lack of reporting tools to calculate online SPC, lower quality rates were reported by them, lack of real-time analysis and actions, and lack of visibility into process efficiency. So what we gave them, again, very simple solution: real-time data acquisition from filler heads, from where the ingredients are getting filled, and weighing scales values. So I have both the data for comparison. Then SPC, statistical process control, and control charts for analyzing fill weight data. Then end-to-end integration with SAP for PO extraction and confirmation. So I have a operator console, very simple tab, which is next to my machine. I go to select PO. It shows me which are the POs which are there. I select the right PO, and then I start my operation. OE is calculated in real time for each filling line. Operators enter reasons for downtime on operator console. So you have to enter necessarily so that you can select the next PO. And then reports are automatically generated for OE, utilization, MTTR, MTBF. See, once data is available, Anant and Babu will agree to me, then you can really play with that data. Data is the new oil, it is said, because without correct data, I really cannot take my correct decisions. And if I don't take correct decisions, obviously I'm going to lose very important resources. So benefits are achieved key ingredients traceability of 98%, which was earlier not known to them. Then achieved CPK of 1.33 within 3 months, they said. Now data is transparently available, so everybody is alert. Now I cannot fool around with the data. And double-digit improvement in OE is what they have reported. So looking at this, it got implemented globally on a cloud platform on Microsoft Azure. So this is like, I wanted to show it schematically, that you have a shop floor, you have fill, fillers, you have a data acquisition device, then you have Microsoft Azure Edge, DMZ is again, layer, and then you have IoT Hub, Data Factory, Cosmos DB, R Analytics, and apps. I'm telling that because I know because it's a NASSCOM event, so there are going to be IT companies also, and you are familiar with all these components. Microsoft Azure PaaS we selected over there, and these are some of the dashboards which you can see easily. So graphical representation, dashboard techniques are so improved now. The way you see it on your car dashboard, you can see how your machine is performing. So you will not run your car if you don't know what is the speed, do you have fuel or not. Same is applying to your machine, that your machine dashboard, is my temperature right? Is it filling correctly? Is it running properly? Is it down? Why it is down? And then the solution costed for the lighthouse plant just under 50 lakh Indian rupees. But the results were amazing. Improved OE, I told you, double-digit OE improvement. Quality got improved because of availability of transparent data at all layers of stakeholders. And the timelines was about 12 months implementation because we had to take out data at multiple levels and understand their CP, CPK concepts. And within 6 months, they said their investment got covered, and now it is getting rolled out at 16, 17 locations globally. Yeah, thanks, Babu.
Fantastic. I think that was quite an interesting one. It was probably a larger scale in the way of solution. You can say something about this. This is also quite an interesting.
So every shop floor has overhead cranes, and I know for sure because I worked on shop floor in Godrej and Boys. Ours are lost because the crane is down, and then you are not able to move your material. And most of the time, the challenges are either there is overload or somebody has missed to find out when is the preventive maintenance, or there is some accident, there is a crash. So safety is also very, very important in overhead cranes. So in this particular example, they wanted to know the crane downtime and uptime, then individual parameter reporting like weight, how much weight it is carrying, how much energy it is consuming, and what is the load right now. And if there are any safety related geographical limits, then there were some sensors put by them, but we got that digital data from there. So total power consumption of individual motors, consumption of the crane, downtime and uptime, again with the reasons, reports available in shift wise, daily, weekly, and as I mentioned to you, the safety. And they have implemented this the dashboard on a TV, and it is all the time visible to everybody over there. So it is reminding that you have to take an action if the crane is down, or if it is overloaded, it gives you alert over there. Again, the cost is under 50K per crane. Improved OE, downtime analysis available, safety parameters were captured and regularly reported, 4 to 6 weeks per crane, and 6 to 12 months of ROI. And I would sincerely encourage all SMEs to look at this as well as your utilities, because these are the equipment which are in dark. By putting sensors, you bring them into light, and they are throwing data, important data, which will save millions of rupees for you in return. Yeah, thanks, Babu.
Absolutely, I think it's very, very relevant. I think there is no cost we can ever tag for safety. So it's really a fantastic example. I think we should, interest of time, we should move fast. So if you will allow me, I think this you have very clearly explained, already shown the dashboards, how it looks like. So the look and feel of a solution also makes it very simple and easy for people to understand. So we move on. Some of the examples of the dashboard, I think it's really clear. We would like to come back to recap. Actually, so from all these examples, we have seen few examples. Of course, we will have a couple of demos in some time. So in that, we would like to come back. Are we convinced? Is it really, why is it, again, can we come back to that? So I think here, Prashant, we come back to the topic of the myths.
True. So again, most of the SMEs to whom I have met, they say it is for, it's a high-tech dashboard. It is nothing more than that. I know I have streamlined all my operations. I know how many components are getting manufactured. It is on, I can get information. So sometimes it is, there's a misunderstanding that it will displace workers. No, it will make workers more accountable and more intelligent. Then IIoT requires greenfield sites. Absolutely not true. It is implemented at multiple locations in brownfield sites. Your conventional machines can also be converted into intelligent machines by putting sensors. To go digital requires 100% readiness. There is nothing like 100% readiness. Now is the time, which I always say, because when you implement IoT, you get savings which are for life. It's a recurring saving. It's not one-time saving. Then continuous improvement is costly with IoT. Absolutely not true. The technology is available, accessible, and continuous improvement is the only mantra if you have to remain competitive in the world. And IoT is not feasible in emerging economies. It is feasible, it is required. If I don't implement Industry 4.0, then I will be, lagging behind my competition. So I'll lose my competitive advantage. Yeah.
Thank you. I think we clearly are breaking these myths. I think it's really important to realize this. And so something about
this is my most favorite slide. So what gets measured gets monitored. What gets monitored gets visualized. It gets analyzed. What gets analyzed gets optimized, and what gets optimized gets monetized. So unless you capture data, real-time data from your machine without manual intervention, with really simple technologies which Dr. Anand demonstrated, we will not be able to monetize the benefits. And these are benefits in cash. Whatever we have implemented, all of them have said that they are seeing double-digit saving. I know for sure one plant, which is about 100 crore, their internal team did this implementation, and he is proudly saying that he has 50 injection molding machines, and there is no breakdown maintenance in last 5 years. Can you believe this? And it is possible only because he is meticulously capturing data, and it is available on the dashboard. So if a 100 crore turnover plant can do that, I'm sure anybody can definitely look at it and start today. Yeah, thank you.
Quite clear, I think, and it's always it's quite clear from this whatever we have seen that this is easy, and it is something which we can really look at. So are we done? Actually, no. We still need to come to one fundamental question about the how and how to. And I think here, from what we have seen, I think it is very clear that you have showed the time frame it takes. Some of it is taken in weeks, some of it has taken few months. But the question which I want to understand and address is how do we do it? And is there a roadmap, and can we say there is a toolkit? What's the tools we can pick and choose? So while exploring this, this is something which Dr. Anant has, he explained part of it already. So I hear it's something which is interesting. We can hear from Dr. Anant.
Thank you. I think that we just added this to just emphasize the fact that even legacy machines can be connected, which is going to be a major population of machines that are there with the SMEs. And these legacy machines, as you know, as Prashant was saying, once you connect them, you are able to monitor them, you can visualize them, you can optimize them and monetize them. And therefore, you know, for connecting to legacy machines, there are very simple techniques that, you know, one can explore from an SME perspective. All that you need to do is to have a very simple internet connection and then have edge devices that can connect to machines directly and collect data. There are so many machines, there's edge devices available commercially today. So you can definitely, if you refer the web, you can get the appropriate edge device, which can connect to machines with some IoT sensors connected to the machines. And the edge devices will have the capability, edge computers, as they say edge devices, I'm talking about edge computer, will have the capability of acting like a computer locally in your plant. And they can take care of security, they can host some applications, they can have data adapters for different types of machines and different types of data, and they can also provide you outcomes like how we were talking about in various cases, you know, providing energy, providing productivity that Prashant was talking about, OEE, CPK, CP, CPK, or you can talk about, you know, energy or production energy optimization, providing some information to an operator to do some assembly job. All of those can be achieved with a simple edge computer and a tablet. So all that you need is some IoT sensors, edge computer, and a tablet to start off connecting to a legacy machine. And you can connect up to 5 machines of almost ₹1 lakh per machine. So 5 machines or so under 5 lakhs. And by digitalizing, you are improving your COQ, improving your productivity, throughput, quality, safety, etc. So I think it's definitely worth a try. I just thought that we should emphasize this fact from an SME perspective. So this slide was added.
It's something interesting, and the payback within 6 months or within a year.
Yes.
Something which is, you know, within a budget cycle, if you can realize a payback, there's nothing better than that to make sense.
Yes.
Interesting. We can see today where we are actually, and we had this slide where we said manufacturing tomorrow, but actually it is not tomorrow, it's already today. So I think thanks to the example shown by both of you, Dr. Anant, Prashant, we could see that these IoT devices, these solutions are penetrating in all the aspects of a shop floor. And actually I can even scale it up to a business level itself. So I think it's very clear that this is already happening. So it is there today.
Right.
So I think in this context, we are coming to the last few bits of this. What is the roadmap for this? What can we advise to you know, the small and medium sector industries, how to go ahead with this? What is the kind of thing which we need? If you'll allow me, I will explain this quickly, but it's quite elementary. Basically, I think the basic problems need to be identified. Which we would like to address? Is it a cost or is it efficiencies? I think if the business is looking at that, they can define the scope. And there, of course, at some point of time, you get in touch with the solution providers who can understand your business. And it's about mapping the current state and quantifying the objectives. What can be the outcomes? So when you actually map the state, you will realize the real truth. And that would be important to define those with the objectives. And again, we have the good guidance, we have so many tools. So using the right technology, we can choose the best ones which are appropriate for the case. And as Dr. Anant has always said, the minimalistic approach, you don't need to go for the whole scale. You can go for something which is simple, which addresses the core of the problem. That is a key step. So once you define on this, we need to execute with a commitment. And From these examples which we have seen, it takes a few weeks to months for the execution. And I think it is advised always to run the system for a few months so that you can see that it is performing and it is consistent, and analyzing the results to know how far we are reaching to the objectives. It's clear that we can definitely achieve the objectives by making these breakthrough technologies. And still we need to continue to handhold the team, because there are new adopters to this thing. Technology is got to be handled and understood by the people who are utilizing this, and stabilizing the system, which we can definitely take a month. And beyond that, there is definitely a potential. Once you have tasted success, you can definitely scale up, you can extend. I think this is a kind of a simple roadmap which takes a few months to run, with a kind of not so easy but more complex solution. It can scale up a bit more, but I think this is what we have seen after interacting with the experts, that we advise the following in a simple way like this. And I think to bring the last piece of this, we also discuss what is a toolkit which we can visualize, and how to suggest what can be applied. And so when we looked at all the discussions, both Dr. Anant and Prashant had said there are different layers to it. The first layer is like a business application, which defines the solutions for the different solutions of what if scenario, performance, and improvement and optimization. But we can also add on to it, create the platform, so that we can go for a digital factory platform, add on to analytics or automation. And if we go further, we can actually go with a connected cloud platform, because this is where the cloud comes in. This is the power of not just having everything within one site. You can actually connect to the cloud, so you have a global kind of platform. So depending on the case, we can invest in the applications layer by layer. And the interesting part is, so these are some of the the solutions we have seen: autonomous robo, augmented reality, IoT devices, sensors. For sure, these can be chosen and applied in the different scenarios. In a business, you can have a autonomous robo or an IoT device, or we can also fix data acquisition devices, sensors, in different aspects of the business. So here, Dr. Anant, what is your take on this? Is there a minimalistic approach even in this?
Yes, and as you can see, if you look at the data acquisition on the left-hand side, if you can just show the highlighted part, the data acquisition connecting to the digital value platforms or to the business application, all that you see in green is the minimalistic sort of approach one could take to start off with. So it is just in this whole scope of Industry 4, we can actually carve out a minimalistic approach to start off the operation, the journey. Industry 4 is a journey. It is a continuous journey. And as you start getting benefits from Industry 4, you can reinvest and build more and more sophistication to your Industry 4 platform, by investing in platforms and in other data analytics and big data. But to start off with, we can start with a simple IoT device, solving a problem that Babu was talking about in terms of how to approach. We start with the problem or a couple of problems, create a solution in a bottom-up manner to sort of solve those challenges, get the benefit, reinvest that for more sophisticated applications, get much more sort of advantage from Industry 4. And that is how it is evolving in the industry globally. And that is what I think all of us would probably agree to prescribe for anybody who's starting. So start small, but then we can expand and sort of harness the entire sort of advantage of Industry 4 across what is being shown in this slide.
Yeah.
And finally, sorry, go ahead, please.
Yeah, no. So I think you said it quite clearly and very succinctly. I think it's all about finally choosing the right solutions. We need to choose the right solutions to solve the problems which we anticipate. And then, of course, I think creating competitive advantage. This is a game changer which we should look at.
Yeah, that's right.
So that was it from the panel discussion. Actually, we have a bit on the gone on the time a bit. So I think without much further ado, we have a few minutes left. So I would request to go into the demos. If it's possible, Mr. Mani, because we have less time and we have also a few questions to answer. So I would see if we can restrict to at least one demo and then go into the question and answers.
I saw the questions. I think questions can be directly answered through a message.
Yeah.
Probably you can see the demo, which can correlate with what the speakers have spoken.
Okay.
Even 2 minutes extra is okay, but let us finish it.
Yeah, so I think we can go to the demo. We will start with the first demo. Mr. Deepak Verma, you can share your screen with the demo, and would request you if you can make it quick within 3 minutes so that you can get the message across.
Yeah, I'll do that, but you may need to stop sharing. I'm unable to start sharing. Yeah.
Yeah.
Give me a moment. Okay. Just give me a moment. Okay, guys, you are able to see my screen now?
Yes.
Okay, I'll try and make it as short as is possible. I think the demo that I'm going to do is the actual, the video of the actual implementation of Industry 4.0 in an MSME. This was a project which was undertaken as in collaboration with NPC and Asian Productivity Organization. The implementation takes care of all the points that we discussed here: the minimalistic approach, the easy to implement approach, the tally of manufacturing solutions, as it was mentioned. So this video has 3 parts. The first part talks about the challenges which the company had. The second part talks about the actual solution, and the third part talks about the benefits that they achieved out of it. So if that be the case, I'll start with the video.
Conceptualized.
Can you hear the?
To drive the smart manufacturing
Can hear,
transformation
yes.
Among the micro, small, and medium enterprises of India. Accordingly, an MSME unit from automotive sector, Vibgya Automotive Private Limited, was chosen for the demonstration project. A diagnostic survey was conducted regarding the feasibility of applying relevant smart technologies in the demonstration company.
For our kind of industry, MSME, or small or micro company, addressing the material shortage could be the first challenges for us.
The second challenge that they had was in terms of the rejection reasons. There were a lot of rejection in the line, quality problems.
The performance measures like overall equipment effectiveness, or availability, the downtime hours, they were all sort of erroneous.
The last, but not the least, was the challenges that they faced in terms of raw material availability. Because of this lack of insight, what was happening was the production was getting affected.
Given the issues identified under various areas, smart solutions were proposed.
As these were the 4 challenges that was faced by the company, and once we understood the challenges, we worked towards and started looked to implement a solution which was easy to implement. We chose a platform which hosted the different solutions which would address the challenges which the company faced. So I'll go to the details of the solution and stop at the relevant relevant point to explain a bit of the solution in detail.
By using a digital attachment to the regular measuring instruments like vernier caliper and dial gauge, this digital attachment would send wirelessly the information. And therefore, every measurement that was made was recorded accurately and objective.
As you can see, this is the quality solution in action. What you see here in the tablet is the control plan, the different characteristics that need to be measured at each point, each production or a quality station comes up automatically. As soon as you choose the part and the station, the different parameters do come up. Now, these are available here. Once the measurement is done using the digital vernier here, the data automatically goes into the tablet, and the tablet validates that measurement. Specific reasons are also captured in the during the time of the measurement. Since this is a Bluetooth device, there is no wired connectivity, so the measurement of the part can happen, and there is no need for anybody to make a note of the details. There's no error when the value is being entered manually. The data from the vernier directly goes into the tablet, and it is made available instantaneously across the production shop. So look at this. If you look at it, there's a validation which happens. So there is, since it is out of range, it is actually asking for a reason. And coming to the second solution, this again, what we have done is, I'll stop it here, to monitor the status of the machine. What we are using are simple current transformers, which then connect to a sensor, and which then sends data onto an IoT device to monitor the status of the machine. Now, the status of the machine is monitored basis the current consumption of the machine. So there are no controllers or PLCs which are in place. It is pure, simple analysis of the state of the current consumption, and basis the current consumption, the state of the machine is arrived at. So this technology ensures that this production dashboarding or this, the monitoring system can be made available even for machines which do not have PLCs or any controllers. So the node, the data is sent to an IoT device, and details are available for view by the production manager at any point of time. This is being seen, and the IoT device that we have here also acts as a server. There is no need for any additional servers to be purchased. The IoT device itself acts as a server. In fact, the device platform has 3 or 4 solutions bundled together, which can be utilized by the SMEs.
Okay.
The third one is the material tracking solution.
Deepak, I think I will have to cut you off because I have to go over the other example. So sorry about that. I think I would request Mr. ATS to quickly jump into the share.
Babu, you can share the company's name in the Q&A session.
Yeah.
Well, that is important because who gave the demo has to be there.
Yeah.
The details of the company can be given in the dashboard.
Yeah.
Okay. Q&A session. Yeah.
Thank you, Babu.
Yeah.
Sorry.
Yeah, Mr. ATS, please.
Yeah. Are you able to see my screen?
Yeah, we can see that.
Yeah. Thank you, Babu. It's very pleasure to explain our product. This is InnoMind product. This is CMMS product. It's a maintenance management application what we have developed with IoT enablement, and it's having that models. What if you have, we can add all the assets what you are having. That is the machine what you are having, and we can add all the machines, and we can enter all the data of the machine, whether it is a high-level data. You can define what are the detail of the machine. We can upload the document for reference, and those things we can add. And we can add all type of maintenance schedules, planned preventive maintenance, what you are going to do for that machine. That we can, everything you can upload, and then we can add the users. Once you add that assets, and when you add that schedules, what you are going to do, and then if you use the add assets, the application is ready. As Mr. Mani told earlier, it's a ready to use application. If the data is ready, we can implement the application within 1 or 2 days. And this is a cloud-based application. We are giving it in the SaaS-based application, so we can start using the application from a week time maximum if the data is ready. And you can monitor all the work orders. When the schedule is triggered, that you will come to here, you can assign to the person to whom it has been done, and we can monitor the breakdown tickets or any preventive maintenance. We can add the conditional monitor, any type of work orders you can execute through this application, and you can monitor what are the things happening in the dashboard, or you can see it in the detail in the reports. In the dashboard, you can have all the widgets. What are the preventive maintenance new status? What are all in progress? If it is an SLA defined, we can see the overdue and also the breakdown tickets which is generated. This interactable dashboard, and you can see the what are the schedules planned, what it is completed, and everything you can see in the dashboard itself. What is the schedule of how much is assigned? What is the uptime of the mission after considering the breakdown downtime and the preventive maintenance downtime? And also you can see the PPM compliance, how much you have planned, how much you have executed, and also you can see the work order by category. What is the percentage of work order on preventive side? What is the work order on breakdown side? Here you can see the average resolve time, average response time for any ticket, what is the on-time arrival, and what is the fixed time, first time fixed rate. If the technician is attending the second time, you can see the first time fixed rate, what is the, how best he is planning. Those things we can see it. We can see the repeated problems, what is the top problems, what is the SLA compliance, and you can see the comparative reports are trend of how many hours is being worked, what are the breakdown calls, what are the spares consumption, and also you can see how many assets we are bringing to the system.
I think the software side is fine, and probably people can connect with you and then look at the detail.
Yeah,
but
okay.
Yeah, we can go to the next presentation if it is there.
Yeah. Okay.
But we understand your capabilities in software.
Okay.
Probably we will ask people to connect because you have some use cases on that.
Yeah. Okay. Thank you, Pani.
Yeah. Thank you, ATS. I think Mr. Krunal, you have a few minutes.
Thank you. I'll just quickly share my screen.
So Kridal, just give the real-time feel of the
yeah, sure.
Yeah. Not go into very detail of configuration or anything.
Yes, what I'll do is just I'll show you like this is the one of the use case which Mr. Prashant sir has shown to you. So this is a very simple dashboard, and it's a very plug and play kind of solution to any kind of machine, where you can connect different sensors to it. You can have, if the machine has different protocols capability, you can get data from those like OPC, Profinet, Modbus, Modbus RTU, or if it is a simple digital proximity sensor or a temperature sensor, current sensors. So we can take the data, and I'm trying to show you simple dashboard over here where you will get all the gist of the what's happening in your plant right now. So how much is the current production count, what is the good and bad count into it, what is my CPK, standard cycle time. I can see my previous shift OE, how much I have achieved in that, current shift OE, what is still now. Also like current OE parameters for availability, performance, and I can also have a comparison of the actual cycle time versus the standard cycle time where I'm there. I can also see my production trend, like at every hour, how many counts I'm producing from my machine. So this is just a quick, and it's very easy to set up in any plant. If operator is trained, he can do it by his own way as well. Also, I would like to show you statistical process control. Like if there is a critical parameter, for example, you are measuring a bearing diameter, then you can see the different trend. So this is a simulated setup. Actually, we have created in our Center of Excellence IoT lab over there, which we have implemented for our one of our good customer. So we are having a real-time data from a simulated machine over there, and from where I'm going to trying to show you this real-time data with that. So along with this, like if you need a reports, I can show you like for my previous day, what was my OE for first, second, third shift. If I go to the summary part, I'll get more details like what was my total downtime. If I want to see my downtime logs, like what were the reasons for my previous shift, so that I can see over here in a pie chart. In summary, like individual defects which has happened on the machine, that I can see like how much time it has taken. And if I need to go in more detail, then each and every delay which has happened in my production, I can trace down that. Also, there is a waterfall report which can easily generate it from the system for your previous current shift details. So how much was my total time and these things, and for my downtimes, what were the different reasons from it.
So in the availability of short time, this is a platform. So you can connect machines to data acquisition device, and from there the data comes here, and you can run n number of analysis reports. Users can configure themselves. It is available on premise. It is available on cloud, and it is completely scalable. So
thank you. Thank you, Prashant.
Thank you. Thanks, Krina.
Thank you. Thank you for providing opportunity.
Coming
Thank
to
you.
an end. Thanks, Mr. Babu. Thanks, Dr. Anand, and thank Mr. Prashant for very detailed explanation of how this IoT 4.0 is going to be useful for the industry. Now it is up to SICCI and AIMA to go further and find out, is there anything which we can have a catalyst to find out whether this implementation can be done. And we have to work on the policies with the government side and the institutions to support this activity, because it's very interesting to see our ROA is within the 6 months to 1 year. Possibly many of the institutions may be happy to support this, fund this activity if it is presented very well. Probably we can work together to find out whether this can be solutions which we can look at from either the government or the institution. Because we know that SIDBI wanted to support this kind of activity, but it has to be presented as a group so that we have a benefit of going to a bank, as well as there is a largeness in it, and also able to give back to them without much problem. Thank you very much for the patient listening of most of the people who have been there, except 10 people dropped otherwise, and I think the whole crowd is there. And there is a good amount of possibility for SME in software to go back to either Prashant or Dr. Anant and find out how they can work together in their own hometowns, and probably they can be an implementation partners. They can also support it with other factors to implement these services to small and medium in their own towns or own states. With this, I thank SICCI, I thank NASSCOM for organizing this event, and thank you everyone who have been part of this event. Thank you very much.
Thank you.
Thank you very much. Thank you.
Thank you. Thank you so much,
Thank you,
Mani,
sir.
sir. And a thank you to our esteemed panel of speakers for delivering such a fabulous and informative webinar. And above all, thanks to our patient audience for joining us for this session. Thank you, everyone. For any further queries regarding this webinar or to connect to any of the speakers, please feel free to write to me at neha@nasscom.in. Thank you.
Thank you.
Thank you.
Thanks, everyone.
Thank you and have a good day.
Thank you.
Thank you.